Multiple choice questions on numerical methods. The first question, the differences of constant function are. This is the first question. So we know that the differences of constant function is equal to what? 0. For example, if we take say here the constant function, say f of x is equal to say c, f of x is equal to say c is a constant function, then suppose we take the first forward difference, then it is equal to f of x plus h minus f of x. So it is f of x plus h is also c and f of x is also c. You can see here the forward difference is what? 0. The next example, which method is used to solve the first order ordinary differential equation? Now the Newton-Raphson method is used to solve algebraic or transcendental equations. Again, regular Pauli method also. Lagrange's interpolation is used to approximate the polynomial function, but the Runge-Kutta method is used to solve a first order ordinary differential equation by using numerical techniques. Now if delta f of x is equal to 0, then either delta is 0 or f of x is equal to 0, delta is 0, f of x is equal to 0. The correct option is what? Does not mean that delta is equal to 0 or f of x is equal to 0. Which of the following expression denote the Runge-Kutta second order formula? We know that this is the formula for Runge-Kutta second order formula. To find the square root of a number by c by Newton-Raphson method means to solve an equation. Now suppose we want to solve square root of c. Suppose the square root of c is equal to x. Then if we square on both sides, then c is equal to x square, and this implies x square minus c is equal to 0, and therefore our equation is f of x is equal to what? X square minus c for Newton-Raphson method. So the correct option is what? X square minus c equal to 0. Every polynomial equation of degree n has exactly n roots. Suppose the roots of the equation f of x is equal to 0 lie between a and b, then bisection method the roots lies in the interval x is. Now when the root lies in the interval x, if f of a into f of x is less than f of xr is less than what? 0. So the correct option is what? F of a into f of xr is less than 0. If dy by dx is equal to 1 plus y square with y0 equal to 0 and h is equal to 0.51, then what is the value of y of 0.5 by using Euler method? Now the given, given y dash is equal to what? Y dash is equal to dy by dx is equal to 1 plus y square. So here f of xy is equal to f of xy is equal to 1 plus y square, and initial conditions are y0 equal to 0, y0 is equal to 0 and h is equal to 0.05, and we want to determine y of 0.05 by using Euler's method. So now here the formula for Euler's method is y1 is equal to y0 plus h f of x0 y0. So here x0 is equal to 0 and y0 is equal to 0, h is 0.505, so y1 is equal to y0 is 0, h is 0.05, and f of x0 y0 means what? F of 0 0. So f of xy is what? 1 plus y square. So this is equal to what? 0 plus 0.05 into 1 into 1. So answer is what? 0.05. So the correct option is what? 0.05, the option number D. Y dash is equal to x square plus y, y0 equal to 1, then the value of y at x is equal to 0.1 by using Euler method is again the same example. Here the f of xy is equal to, what is f of xy? X square plus y. So f of xy is equal to x square plus y, then initial condition is y0 equal to 1, initial condition y0 is equal to 1, and the h is not given. H is what? 0.1. H is missing here. H is 0.1. So x0 is equal to 0, y0 is equal to 1, f of xy is x square plus y, h is 0.1. So y1 is equal to y0 plus h f of x0 y0. So y0 is equal to 1 and h is 0.1, f of x0 is 0, y0 is 1, so this is equal to 1 plus 0.1 into f of 0 1. So what is f of 0 1? 0 plus 1, that is 0 plus 1, that is 1 into 0 0.1 is equal to 1 plus 0 0.1, so it is 1.1. So the correct option is what? 1.1, option number D. The formula to find root of the equation f of x is equal to 0 lies between a and b by regular falsy method is xr is equal to, we know that the for regular falsy method our next root can be calculated by using the formula a f of b minus b f of a divided by f of b minus f of a. So this is the correct option. Now dy by dx is equal to 1 plus xy, then the value of y dash 0. Now since dy by dx is equal to 1 plus xy, this is nothing but the, now since dy by dx is equal to, since dy by dx is equal to 1 plus xy, so this is nothing but the y dash of x is equal to 1 plus xy. So we use this notation and want to determine y dash of 0. So y dash of 0 is equal to 1 plus 0 into y, so this is equal to what? 1. So the correct option is what? The correct option is equal to, correct option is equal to 1. Which of the following numerical method is widely used to solve the first order ordinary differential equation? We know that these four methods, Taylor series, Euler method, Euler method, modified Euler's method, and Runge-Kutta methods, are all are used to solve first order ordinary differential equation, but the most commonly used method is what? Runge-Kutta method. The nth difference of a polynomial function of degree n is what? Constant. We know that, that is, suppose for example if we take the say f of x is equal to x, and if we apply the first forward difference delta f of x, we know that delta f of x is what? F of x plus h minus f of x. So this is nothing but the x plus h minus x. So you can see here the first forward difference is what? H, which is nothing but the constant. Similarly you can extend the formula, you will get the nth difference of polynomial of degree n is constant. Which of the following numerical method is applicable to solve first order ordinary differential equation? Again bisection method is used for to solve algebraic and transcendental equation. Euler's method is also used for ordinary differential equation. Which of the following numerical method is not used? So bisection method is not used to, because this method is used for to solve to obtain the approximate solution to algebraic and transcendental equation. So what is delta a of x? Now the delta a of x, so we know that the delta of the first forward difference of f of x is f of x plus h minus f of x. So this is an f of x is equal to what? A raised to x. So this is nothing but the a raised to x plus h minus a raised to x, as we know that a raised to m plus n is same as a raised to m a raised to n. So if we take a raised to x outside, the inside the bracket a raised to h minus 1, so the correct option is what? A raised to x to a raised to h minus 1. A polynomial equation with rational coefficient has okay, so this equation I think it should be a rational roots. Okay, next a Newton forward difference interpolation formula is applicable. Newton backward is used the near the end of the tabular values. Backward is used near the end of the tabular values. Newton forward interpolation formula is applicable near the beginning of the tabular values. This is used for beginning of the tabular values. Shift operator E is defined as E is equal to f of x is equal to f of x plus h. Which of the following is a transcendental equation? A equation which contains logarithmic function, algebraic, logarithmic, exponential, trigonometric function are called, or inverse functions are there, then it is called transcendental equation. This equation contains sine inverse of x, so this is what? Transcendental equation. Newton-Raphson method depends on initial guess, iterations, first derivative. It depends on what is the Newton-Raphson formula. The formula is what? Y1 is equal to y0 plus f of x0 divided by f dash of x0. So the value depends on the initial guess as well as a derivative. Okay, it depends on the first derivative as well as initial guess. Using Euler's method, find the y of 0.2 and h is given is what? 0.1. So now we want to apply the Euler's method here. The function is given f of xy is what? Y square plus 1. F of xy is y square plus 1, and initial conditions are y of 0 equal to 0 and h is equal to 0.1, and we want to determine the value of y of 0.2. Means what? We want to determine two iteration here. For the first iteration we obtain y of 0.1, and then the next iteration we'll get y of 0.2. So here given x0 is 0, y0 is 0, f of xy is y square plus 1, h is 0.1, and x1 is what? 0.1. That is x0 plus h, that is x0 plus h is what? 0.1. So y1 is equal to y0 plus h, f of x0 y0 is equal to y0 is 0, h is equal to what? 0.1 into f of x0 y0 is 0 0. So this is equal to y1 is equal to 0.1 into f of 0 0, that is 1, so it is equal to 0.1. So y1 is 0.1, y1 is equal to 0.1, y2 is equal to y1 plus h, f of x1 y1. So y2 is equal to y1 is equal to 0.1 plus h is equal to what? 0.1 f of x1 y1. So x1 is equal to what? 0.1, and y1 is what? 0.1. So what is f of xy? F of xy is y square plus 1. So this is nothing but y2 is equal to 0.1 and y square plus 1. So this is what? 0.1 and y square, that is y square 0.1 bracket square plus 1. So this is nothing but the 0.1 plus 0.1. This is nothing but the 1.01, and this is nothing but if you multiply 0.1 into plus 0.101, so this is equal to 0.201. So the correct option is what? 0.201, but there is a no option 0.201, so it is what? 101. I'm going to check here. It is 0.1 into 0.101 and 0.201. So the correct option is what? y1 is equal to y0 is 0, 0.1 into f of x0 y0 is 1. y1 is 0.1 and y2 is equal to f of x1. x1 is also 0.1, y1 is also 0.1, 0.1 plus 1. Yes, it is what? 0.01, 1.01, and this is 0.101. So the correct option is what? 0.201. So the correct option is not there. This may be option. It is 0.201. This is, option is not there. In modified Euler method, the formula for y12 is equal to y0 plus h by 2 f of x0 plus f of x1 y1. So this is the correct formula for y12 for modified Euler formula. In both the digits 12.27 are correct, then relative error. As we know that if the number is rounded to n decimal places, then the error for upper bound for absolute error is 1 upon 2 into 10 raised to n. So here it is given number rounded to 2 decimal places, so it is 1 by 2 into 10 raised to 2. So this is nothing but if we solve this, we get 1 by 2, that is 0.5 divided by 10 raised to 2, it is equal to 0.05. Since we want to determine relative error, so again we want to divide by correct value, that is 12.27. So if we divide by 12.27, it is equal to 0.004. So this is the correct option, 0.004. Okay, e raised to minus 4. Which of the following the general formula for Euler's method for successive approximation? So we know that yn plus 1 equal to yn plus h f of x and yn. This is the correct formula for Euler's method. In Runge-Kutta method for second order formula, k2 is given by, now this is the k1 h f of x0 y0 k2 is equal to h f of x0 y0, h f of x0 y0 plus f of x0 plus h y0, f of x0 plus h y0 plus h. Okay, so this is nothing but, so it is equal to what, h f of x0 plus this is the formula, h f of x0 y0 plus f of x0 plus h y0 plus h f of x0 y0. So this is the formula for k2. Location of root theorem states that for continuous function f of x has at least one root between a real number a and b if f of a into f of b is what, less than 0. Then a polynomial equation of even degree whose constant term is negative is not delta square divided by e into x cube is equal to delta square divided by e into x square is equal to, now as we x cube, sorry, delta square by e divided by x cube is equal to, as we know that, so this is nothing but the delta square e raised to minus 1 x cube. So this is nothing but the delta square x minus 1 cube. So this is nothing but the delta square x cube minus thrice x square plus thrice x square plus thrice x minus 1, and now since it is a second order difference, this is equal to what, 0, and here the second order difference of this thrice x is equal to what, 6x, and this total term is what, 0. So the it is equal to what, the correct option h is equal to 1. So here d is equal to what, 6x. To find the inverse of a number c by Newton-Raphson method. Now the inverse of a number by using Newton-Raphson method. So again, say x is equal to 1 by c, then we get inverse of the given number. Say to find the inverse of a number c by using Newton-Raphson method is equal to, say the inverse of the given number c is equal to what, x. Say c is the given number, I want to determine its inverse, that is 1 by c is equal to x, then x minus 1 by c is equal to what, 0. So the x minus 1 by c is equal to 0. So this is the correct option. Delta square 3e raised to x by interval difference is what, h. So we want to determine delta square of 3e raised to x. Delta square of 3e raised to x. Now 3 is outside, and delta of delta e raised to x. So this is nothing but the 3 times delta of e raised to x plus h, f of x plus h minus f of x. So it is e raised to x again. So this is nothing but the 3 times delta of e raised to x into e raised to h minus 1. Again, e raised to h minus 1 is a difference constant, so if we take it outside, it is 3 times e raised to h minus 1 inside the bracket. Again, what is delta e raised to x? It is e raised to x plus h minus e raised to x. So again we take e raised to x outside, and this is nothing but 3 e raised to h minus 1 bracket square into e raised to x. So the correct option is what, 3 e raised to x e raised to h minus 1 bracket square. For differential equation dy by dx is equal to x plus y, y0 equal to 1, then Runge-Kutta second order formula, the value of k2 is equal to, so the given dy by dx is equal to x plus y, given dy by dx is equal to x plus y with initial condition y0 equal to 1, and we want to determine the what is the formula for k2. For that we want to determine k1. So what is k1? K1 is equal to h f of x0 y0, and kh is given okay, the h is not given here. We take h is equal to 0.1, so h is 0.1, take h is equal to 0.1. so k1 is equal to h, that is 0.1 f of x0. x0 is what, 0, and y0 is 1. So this is nothing but the 0 plus 1 is 0, so k1 is 0.1, and k2 is equal to h f of x0 y0 plus k2 is equal to h f of x0 plus h, sorry, f of x0 plus h y0 plus k1. I am writing here k2 is equal to h f of x0 plus h y0 plus k1. So x0 plus h, so this is nothing but the h is 0.1 and f of x0 plus h, x0 is what, 0, so it is f of 0.1 and y0 plus k1. y0 is equal to x0 is 0, y0 is 1, so 1 plus k1, 1 plus 1.1. Now what is the formula f of xy? F of xy is equal to x plus y, so it is 0.1, so this is nothing but the 1.2, so the correct option is what, 0.12. So the correct option is what, C, 0.12. dy by dx is equal to x square plus y. Then what is the value of then x0 y0 is, so what is x0? X0 is 0, y0 is 2, so the correct option is what, 0, 2. The missing term, now this is nothing but the 2 raised to 0, 2 raised to 2, this is 1 square, 2 square, 3 square, so the 4 square is what, 16. A polynomial equation with real coefficient have a real root, maybe imaginary root, so complex roots. Okay, truncation error. Now this error arises due to approximation of the formula. Delta 4, as we know that this is nothing but, as we know that delta raised to delta x raised to n, say here, is equal to n factorial. Okay, but if it is here, it is what, what is the largest coefficient? If it is delta raised to 4, sorry, if it is delta raised to 4 of, say here, delta raised to 4 of x cube, then this is 0. But for delta raised to 4, just want to think about the power of 4th term. So what is the 4th power term here? Minus x, minus twice x. The large 4th degree term is what? Minus x, minus twice x, minus thrice x, minus 4x, minus 4x. So this is equal to what? 4 into 3, 12, 12 into 2 is what? 24 into x raised to 4. And what is x raised to 4? Delta 4 x raised to 4. This is nothing but the 24 into 4 factorial. So the correct option is what? 24 into 4 factorial. Suppose the roots of the equation f of x is equal to 0 has lie between the a and b, then bisection method root lies in the interval xr b if f of xr into f of b is less than 0. So this is the correct option, f of b into f of xr is less than 0. Delta, and now here the polynomial having degree n, and we are going to take here n plus 1 power, so its n plus 1 power is what? 0. Now dy by dx is equal to x plus y, then the value of y of 0.1 using Runge-Kutta second order formula here. Okay, so the equation given, dy by dx is equal to x plus y, and I think dy by dx is equal to x plus y, and y0 is equal to 1, y0 is equal to 1, that is x0 is equal to 0, y0 is equal to 1, and h is equal to 0.1. f of xy is equal to x plus y, so k1 is equal to h f of x0 y0, so h is equal to what? 0.1 into f of x0 y0, that is x0 is 0, y0 is 1, so this is equal to 0.1, k1 is 0.1, k2 is equal to h f of x0 plus h y0 plus k1. Okay, so k2 is equal to h is what? 0.1, f of x0 plus h, x0 is what? x0 is 0, 0 plus h is 0.1, y0 plus k1, so it is 1.1. and what is f of xy? It is nothing but the k2 is equal to 0.1 into this is nothing but the 1.2, so this is what? 0.12. and what is y1? y1 is equal to y0 plus 1 by 2 k1 plus k2. So what is y1? Y1 is equal to 1. So this is equal to 1 plus 1 by 2. K1 is what? 0.1. K2 is 0.12. So it is 0.22. And if we divide, it is 1 plus 0.11. So this is 1.11. So the correct option is what? 1.11. So C. The inherent error arises due to, this error arises due to the input value. If it is already error in the statement, then inherent error is occur. Delta n x raised to n is what? N factorial. This is what? N factorial into h raised to n. N factorial into h raised to n. Delta square sine x. Now the delta square sine x is equal to, so here delta square sine x is equal to, or determine the formula for, now delta sine x is equal to f of x plus h, that is sine x plus h, minus f of x, that is sine x. And again if we apply the delta square, then we get delta of sine x plus h minus delta of sine x. So this is nothing but the f of x plus h, that is sine of x plus twice h minus sine of x plus h. Now what is delta sine x? It is minus of sine of x plus h minus sine of x. So this is nothing but the sine of x plus twice h, sine of x plus twice h minus 2 times sine of x plus h plus sine of x. So it is equal to sine of x plus twice h minus 2 times sine of x plus h plus sine of x. So this is the answer for the formula delta square y0. Now delta square y0 is equal to, so delta square y0 is equal to, now delta y0 is what? Y1 minus y0. Now delta square y0 is equal to delta y1 minus delta y0. So this is nothing but the y2 minus y1 minus y1 minus y0. This is y2 minus 2y1 plus y0. So what is y2 here? Y2, this is y0, y0, y1, y2. So y2 is 1, y2 is 1 minus 2 times y1. So y2 is 2, so this is 2. And what is y0? Y0 is equal to 1. Y0 is equal to 1. So here 1 plus 1 is 2 minus 4. So answer is what? Minus 2. Answer is what? Minus 2. Now delta of x divided by x plus 1. What is delta of x divided by x plus 1? Now this is equal to x plus h divided by x plus h plus 1 minus x divided by x plus 1. So here difference is what given? Difference is not given. Okay, take h is equal to 1 here. Take h is equal to 1. So this is equal to x plus 1 divided by x plus 2 minus x divided by x plus 1. So here if we multiply here, this is nothing but the x plus 1 bracket square minus x into x plus 2 divided by x plus 2 into x plus 1, x plus 2 into x plus 1. So this is nothing but the x square minus twice x plus 1 minus x square minus twice x. So this is nothing but plus twice x. So this is x square get cancelled, twice x get cancelled. Here 1 divided by, on the denominator it is x square plus thrice x plus 1. So 1 divided by x square plus, this is what? X square plus twice x plus x, that is thrice x plus 2. Thrice x plus 2, not 1. So there is no correct option here. X square plus thrice x plus 2. Here this is the correct option. Just make the correction, that is x square plus thrice x plus 2. Now which of the following equation is an algebraic equation? Now here exponential, here trigonometric, so not exponential. Here also not algebraic equation. This is not algebraic equation, but here this is what? Algebraic equation. All these remaining 3 equations contain either trigonometric or logarithmic function. The inverse square root of a number c. So the want to determine the formula for inverse square root of c. So that is 1 upon square root of c is equal to x. This implies 1 upon c is equal to x square. This implies x square minus 1 upon c is equal to 0. So the correct answer is what? X square, or you can solve this is equal to 1 upon x square. This is nothing but the 1 upon x square equal to c, and 1 upon x square minus c is equal to 0. So the 1 upon x square minus c is equal to 0. Which of the following method require the higher order derivative? Obviously in Taylor series we require higher order derivative. Which of the following numerical method rarely used to solve the first order ordinary differential equation? Obviously Euler methods, because the error is very high. For the shift operator e raised to 4x is equal to what? F of x plus 4h. Y of 0.1 in Euler method you can solve this. For Euler method, real root of the equation x square minus 16. Now here f of x is equal to x square minus 16. F of x is equal to x square minus 16. So f of 3 is negative, f of 5 is positive. So f of 3 is negative. You can check here. F of 3 is what? F of 3 is equal to 3 square minus 16, that is 9, minus 16, that is equal to minus 7, which is less than 0. And f of 5 is equal to 25 minus 16, that is 9, which is greater than 0. And therefore f of 3 into f of 5 is less than 0, and therefore the correct answer is what? 3, 5. For the shift operator e raised to m into e raised to n f of x. So e raised to m into e raised to n f of x. So this is nothing but the e raised to m f of x plus nh, and e raised to m. Now e is what? F of x plus h. So e raised to m is what? F of this is nothing but f of x plus mn h, and this is nothing but e raised to mn f of x. So the correct option is what? E raised to mn f of x.